Hello, I'm going to talk about clouds. So, Spring is a film that's pretty much all about nature and landscape and clouds. They play a very important role in our film, and so we have to find a way how to make them in a convincing way. Now, if we talk about clouds, there's of course many different types of clouds, and there's also many different ways in how to make them in the digital realm. There is, cards, there is photographs, there's simulation, there is point density, all kinds of different things. I'm going to specifically talk about the kinds of clouds that are going to be in landscape shots and in big wide shots, and that are there just to fill a large part of the scenery. And it's not going to be so much about simulation. Of course, we'll also address those later on because I'm pretty sure there will be some kind of volumetric smoke simulation in this film, and I'm sure there will be point density and all the other tricks in the books that we can find. Now, but first, let's just talk about the simple clouds that are just there in the background and that are there to make the scene come to life. Now, with this tutorial, I'm actually going to give you a little example file that I made. This is just, boiling it down to the bare essentials to how we made those clouds, and I'll just quickly go over the file, but we'll also construct it completely from scratch. But just so you know how this works in principle. Here we have a cube, and I'm not sure how I will clean up this file for you guys later, but for now this is a cube with a simple material. And the simple material is just a shader. Now, let's look at the shader and its, in its various components. There's nothing really all that complicated about it. In the end, we have the shader part of this whole setup. So this is a principled volume, fairly basic, with some attributes for density and color. And then this is the part where we do the actual generation of the procedural clouds. There's some color ramps here and there. There's one for inverting, there's one for contrast. Now the grunt work of this material is done in here, in the middle. This is a stack of Voronoi textures, and why I chose Voronoi textures, I'll get to that, which are combined in some ways. There is one spherical gradient texture, and that's just there to give us the main body of the clouds and to clip off the ends. And then there's this part, which is the manipulation of the coordinates part of the shader. And then in the end, this is all just about values and texture coordinates. So it's fairly simple. I would say it's like 1, 2, 3, 4, maybe 5 parts of this. All right, that's it. Now let's jump right in and see how this is all put together. All right, so before we create all kinds of weird shaders and materials and textures, let's just set up this scene so we can get some quick previews. First, let me just go and switch the render engine to cycles, and the sampling, for now, the viewport maximum samples can stay like that, nothing too outrageous. Geometry, volume, this is actually very important. Now, the volume step size here determines basically how much cycles divides the volume in space. So it takes kind of these slices through the volume and then it interpolates between them. kind of. I don't know exactly how it works in principle. I'm sure the rendering experts will know how that works. It's just important to know that the larger this value becomes, the more inaccurate the volume rendering representation will be in the rendering, and the smaller it is, the more accurate it is, but also the slower it is. So smaller steps mean more steps through the volume, and that means more rendering. For the viewport rendering, I think I'll keep this around 2 or 5. Let's just put it on 5 right now so we can get some quick previews. Maximum steps, we're not going to touch these right now. Hair, we're not going to worry about hair. But light paths, I'll just limit everything to 2 right now. We don't want to get too outrageous. I'm going to disable caustics, no motion blur, no transparency, and I only have a CPU here anyway, so this is not going to be all that important. Did I forget anything? No. Okay. Now let's set up a world next. I'll just set up something with a slightly sort of blue background, something kind of sky-ish. And then I'm going to take this lamp and I'm going to turn it into a sunlight. And we'll start with a value of 8 and make it roughly yellow. Of course, we'll have to switch on sun. Adds a sunlight. And I'm going to change the size to something that's good, 0.5. That's like 5 centimeters. Okay, I'm used to Blender units, but apparently this is 5 centimeters. Great. Now, next I'm going to split my view horizontally into a viewport and a shader editor, which is just the new kind of terminology for the node editor. Okay, next I can go and select my cube, and I will check use nodes, and it already generates some nodes for me. Of course, we will not use the principal BSDF, but we will use the new and shiny principled volume. And we're going to keep it at the default values for now. But if I Shift Z, I'll get a preview here. I don't actually can turn overlays off, but this should be fairly okay as a starting point to let us tweak things in the viewport. All right. Now, before I start, it's kind of important to think of how we proceed next. So we're going to generate essentially a procedural shader where we can scatter and distribute a large number of cloud objects in the scene. So these cloud objects will most likely all share the same shader. And to get some variety and to not make it too repetitive, we have to be aware of texture coordinates in 3D space. Now, there's different kinds of texture coordinates. We're right now looking for the ones that are more or less working on a global scale. But also we are going to combine those with object texture coordinates. So first, let me set up the main texture coordinates that we'll use. So we will use geometry, position, and this is essentially the world coordinates. This is the position of the object in a 3D space. Then there's another node that we need. This is the texture coordinate node, and this one has all the texture coordinates, the real texture coordinates. There's generated, normal, UV, we all know those. We are interested in object, and object gives us basically the object center as the center of the coordinates. So these are the two different ones, position and object. So let's start setting up the procedural part of our shader. And, well, we have to talk about procedural clouds. If I would just go in and, do the typical thing of, adding a noise texture, they never, for some reason, they never look right. They always look kind of CG, they look like Perlin noise, which is that's what they are. So everyone who knows this kind of procedural texture will go like, ah, I see what you did there. And I mean, it's good as a starting point, and it's also good if you mix different types of textures in the procedural world. But as a cloud texture itself, I would just not. Nah, it just never looks right. So when I was thinking of making these procedural textures, or these procedural clouds, I looked at a lot of cloud reference, and one thing that struck me was that clouds are kind of like these blobby thingies. They're comprised out of many different, the many different blobby volumes. And hey, we have a texture that can generate some kind of weird blobs in Blender, and that's the Voronoi texture. Now, it's kind of a weird one because it's very artificial, and unless you're doing something with polka dots, you wouldn't think of using this as a texture for creating realistic looking clouds, sort of. So let's just take this one here and plug the factor into the density output. Let's just preview this, and we kind of get this murky sort of thing here. By the way, let's just scale up everything so we are working with more or less real world sizes. So this is one cloud component, so let's just say this is around 10 meters. And I think just to make it a bit more visible, I will probably bump down the step size for 1, just for now. Now, to make this a bit more visible, I'm going to add a color ramp. And I'll try and make it really sharp. Now you get this kind of spider web-ish looking thing, but if you take this and you invert it, bam, you actually get kind of these blobby thingies, which are really, really interesting, especially as a volume. Now, let's just separate these two operations here with color ramp. I'm gonna keep the inversion part, so this is gonna turn the texture into these blobby thingies, but then I'm going to duplicate that, and I'm going to make it a normal color ramp, and this one is only gonna take care of the contrast operation. So yeah, that's pretty cool. So what happens if we combine two Voronoi textures with each other? Just to make sure that we're kind of working in the right texture space, let's plug the position output of the geometry node into the Voronoi texture. So now we're working in global texture space. Of course, we're going to have to adjust the scale of our textures slightly. So let's go with 0.5. And now this is position independent of sorts. So I can move around this volume, and you can see the textures will kind of swim in this volume, which if you use it really, really subtly, you can get some nice animation going on. I'm going to duplicate this texture, and I'll plug the same position into the vector, but now I'm just going to use a different size. So let's use 1. So different size of blobs. And I'm actually going to just mix these two together with an RGB node. Here we go. Now we can barely see it, but now we're kind of mixing together. Let me actually make this 1.5 just to make it a bit more dramatic. Now we're mixing together these two different sizes of Voronoi texture. So we got a big blob and a small blob being added together. And we can do this multiple times and we can get some very interesting results. Now, the cube shape is kind of a bit annoying to me because I really want to see what's going on inside the volume, and to be honest, a cube is not really a realistic shape for a volume, or a realistic shape for a cloud. So I could just change the cube and actually model a cloud, but then we're still gonna get these really sharp outlines whenever the volume is hitting the boundary of the mesh. So let's just add a three-dimensional blend, a spherical texture to this object, and that is, of course, yep, here we go. That's of course a gradient texture, and for this gradient we will be using the object coordinates. So right now I'm just gonna collapse these, Control H, because this is really all that we need, position and object. And this one is going to be a spherical texture, and this one is going to multiply with the result of these two Voronoi textures. Why multiply? Well, let me just plug this color output into the density. This is the spherical thing, and in the middle there is currently a value of 1, or a density of 1, and on the sides there is a value of 0. So if we multiply this, we're gonna get this kind of Voronoi stuff happening until it kind of blends out when the spherical texture becomes 0. So I will add a converter math. Whoops. I'm going to choose multiply, and then I'm going to mix it up into the rest. Very interesting. So we get this kind of cloudy thing here. We can even expand it a little bit more by just moving the center point of this contrast operation into the middle. Now you can really see that there's these big blobs and these small blobs that are being mixed together, and we can change the ratio of that because the more we mix the small blobs into the big blobs, they're gonna influence each other. So the big blobs are going to become a little bit smaller, and the small blobs are just slightly fading in there. Now, as you can see, this is already getting us very, very close. So we get this kind of stylized, blobby cloud shape going on. And we can even just amplify that a little bit by adding another multiply at the end, just to make sure that we have a bit more weight to the volume. So what happens if we just introduce another Voronoi texture, just a third stage, just to add some more definition to this? And this one is going to be really, really small, tiny. Let's make it 5. And let's just mix it in really, really by tiny amounts. This is almost a little bit too much. So let's make it 4. And let's mix it in by 0.1. How does that look like? All right, it's kind of getting there. All right. Oh, that looks really promising. Now, this is starting to get a bit slow, so I'm going to turn the step size up to 2. We'll get less definition in the volume, of course. But here's one more thing. Now, the cool thing about this is that we still only have a cube, and that's fairly simple geometry. And this cube has kind of the spherical texture coordinates pinned into the middle. And these Voronoi textures happen in global space. So what happens is that once we move the cube around, the outlines stay kind of fuzzy, but the textures kind of get multiplied with each other, and it gets this very interesting progression. And if we animate this object moving through the space, we can get some really, really cool, cloud movement going on. Well, that's fairly nice. Now let's go for another step forward, and let's make this a bit more tweakable. And what I mean by tweakable is we're gonna make a lot of these objects later on to model our cloudy landscape, and we don't want to be tweaking, the material on various points. Let's just find some values that we can, let's just make a value entry point that we can modify, and and then the shader tree will handle all the variations of it. So you can see that we have 3 different scales here, but we can really just make this one value and a scale ratio, or a couple of scale ratios. So let's just clean this up a little bit. I'm going to insert an input value node, and the first Voronoi texture is going to dictate what value we choose. So it's going to be 0.5, and then we're gonna take this value here, and this is actually 0.5 times 3. So we will add a math node, and this will multiply this times 3. So now we can take this input value in here, pipe it into the Voronoi texture, and this second value, pipe it into the second one, and then this one is 4, so it's going to be 0.5 times 8. This is going to be that one. So it's just a little bit of cleanup. Now we only have one value to tweak once we modify something in the scene. So I can just really quickly change it, do some tweaks without having to change values in 3 different places. Now, while we're at it and we're making things a bit cleaner for ourselves, let's just make this full screen, and let's name this value here. So this is the value, and internally it's defined also as value. So we're going to define it internally as, what is it? Texture underscore scale. And then as a label, we're just going to make it nice to look at. So texture, scale. And that's what is going to be displayed here in the texture. And I'm doing this so later, once this gets linked into scenes, these values can actually be addressed and changed via Python. So it's nice to have a nice and absolute variable name for this. I'm going to make a duplicate of this because I want to just also make the overall density multiplication of the texture tweakable from this one point. So I'm going to call this volume underscore density. And I'm going to plug this into the multiply node. Now the default value of this is going to be 2. I'm just going to shift and cut this thing here to make a nice little clean and tidy node setup. Okay, now we made this little procedural setup. It's okay. It's not really all that interesting to look at. And it's still, although from a distance it looks okay, it looks fairly cloudy, sort of. If we get closer to this, we see that everything kind of starts looking a bit too basic still. So how can we add detail on top of this without destroying everything completely? And while doing this, I'm just going to revert back to the one Voronoi texture. So I'm going to select these and mute these nodes. So we're only looking at the big Voronoi texture here. And how can we modify this? Well, we could add another texture to it. We could blend some more textures with each other. But I really, really like the kind of volume that this texture gives me. So I want to really just distort it slightly, only slightly. And for that, I'm going to use the procedural noise texture, Perlin noise, essentially. Now, how do you actually distort things? Well, there's a reason why I added this texture coordinate node in the beginning, because now I can just take these coordinates and modify them. And by modifying these coordinates, we're bending the texture space, so to speak. Okay. How is that happening? Well, first I'll just move everything a bit further to the beginning. And I'm going to add a noise texture. Now, this noise texture has a very, basic input and output. It has these factor but also this color output. And this color output is really, really interesting if you look at it like from just purely the color information. It turns everything in this kind of disco, into this kind of disco colors. And these colors are perfect to mess around with texture coordinates. Now, texture coordinates, if we display them, they are also just really kind of colors internally, because they're comprised out of 3 different axes. There's the x-axis, the y-axis, and the z-axis. And these axes can just be represented as colors. And in fact, that's what normal maps usually just are. They're just color information interpreted as vector information. Now, what happens if we actually mix this color information into the vector information? So let's just take a mix node. Let's unmute it. And let's blend this color into it. That's fairly cool. So the more I blend this texture into it, the more I am distorting the space of that texture. Now I have to be a bit careful, because as I'm using the position coordinates here, the more I modify this, the more extreme the values are going to get. So this mix node is actually going to amplify things over the distance. So we have to be a little bit more careful with how we deal with these textures. And more importantly, it's also good to think of the texture space that this noise texture is in. In our case, I want to keep the texture space of the noise confined to only the object coordinates. So let's just take the object coordinates into the noise texture as a vector. We really just want to add this color information to the vector here. But as I said, it's going to really amplify the colors a little bit. And also, it's good to think of the noise texture as a curve as a function curve, because that's essentially what it is. It's a three-dimensional function curve. But right now, these values that the curve is in are in positive RGB space. And what it does, if we add something to it, these values will only kind of push the 3D values into one direction. But since we want to distort, we kind of want to subtract a little bit, and we want to push in other places. So if we think of these noise textures as a curve in 3D space, they're kind of these values that are centering around kind of around 1, but not really around 1, because the 1 is the maximum value for this, but they're kind of oscillating between 0 and 1 in various axes. So we want to bring it down by 0.5 to center it around the 0 point. So we can do that really simply just with a mix RGB node. And we're going to let's see, we're going to subtract 0.5. This is already set on 0.5. So now this is kind of oscillating between minus 0.5 and plus 0.5. And what happens is, now when we add this to the Voronoi textures, you can see that they, like, the more we add this, the more they get kind of distorted. They get pushed forward and pushed backwards in 3D space, which is fairly cool. It adds this additional depth to these very simplistic ball shapes. And since I'm doing this to all the 3 different texture coordinates, essentially all my Voronoi textures are distorted in 3D space, and they're gaining additional detail. So to amplify this just a little bit more, I can even multiply these, let's say, by 10. So I'm gonna insert a color value that's greater than 1 here, and this really makes it very extreme, just to show you what we can do with this. So I'm gonna mute these again. But now you can see, the more I add this, the more I'm pushing these blobby things around. So we're only gonna do it really subtly, like by 0.2, 0.5 maximum really. But these give us a nice starting point, and I'm going to Control H and Control H and H, make these things very small, because I'm most likely never going to touch these 2 nodes again. So this makes for a nicer shader graph as well. I can unmute these Voronoi textures, and now you get this kind of mixed situation happening again. And there we have it. Now the only thing I really want to do is base this size also on the scale here. Now it gets a little bit tricky, because we are essentially dealing it in a different space. But let's just, as a starting point, use this output as the scale, just to keep things relative. Now I can, for example, duplicate them. And with that, we can kind of construct, clouds by just combining different volume objects. And that's basically all I did for Spring. So there are these collections of objects. They're spheres in this case, just because they're visually closer to the actual spherical blend texture here. So, for example, I could just go and replace this cube with a sphere. I'm going to choose an icosphere, and then I have to make sure that the outline of the sphere kind of matches with the gradient texture here. And now, since I have a really nice outline to work with, I can kind of combine these spheres at different sizes, and using that I can build cloud landscapes, and the representation in the viewport is kind of closer to what we get at render time. Now, this was actually fairly a crucial point, because I started making these clouds with these big volume objects and point density textures, but it's kind of hard to visualize how the cloud landscape looks like when you're dealing with one massive volume. The good thing is also that once you're making different variations of the clouds, you can really simply link them into different shots, and you don't really need to build all that much once you have a nice little library of clouds. I think the drawback of this is that we are kind of having too many volume objects in the scene, so we're going to get some problems the more cycles is going to intersect between those volumes. So we have to find some ways to optimize this, and maybe bake this down to some sort of cache, or find a way to further optimize it, or avoid intersections between volumes at all. But I hope this gave you a very good idea of how we build the clouds in Spring, just for now. Just for this one particular case, building landscapes, building cloud shots in the landscapes. We're hopefully going to get some more occasions to look at this topic again in the future. I hope you enjoyed this video, and thank you very much, and goodbye.